Thank you for joining us on Physics Around Us. I'm Travis Liggett, and I'll be walking you through the physics of throwing a football. So here we see two students at LMU playing catch on a beautiful sunny day. Today they'll be helping us understand the physics behind the game a little bit better. Two players stand 15 yards away from one another. The player on the left throws a 0.4 kilogram ball to the receiver on the right, releasing it 1.78 meters above the ground. The ball takes 2 seconds to reach the other player, and the receiver catches it at a height of 1.47 meters above the ground. There are four main problems that we'll be looking at during the duration of this video. 1. What is the impulse on the ball immediately after it's released? 2. What is the force on the receiver from the ball after he's caught it? 3. If this were an isolated system, how much work would the passer do on the ball? And finally, 4. Using the work calculated in problem 3, determine the force that the thrower receives from his throwing motion. For this first problem, which is again, what is the impulse felt by the ball immediately after it's released, we have this setup. On the left, there are the givens, which are the known variables, and on the right, we have the solve, in which we use the appropriate equation in order to find the unknown variable. In this case, we're trying to find impulse, so we're going to be looking at change in momentum. Plugging in the appropriate values for the momentum before and after the pass, we're able to find the impulse felt by the ball, which is 2.76 Newton seconds. Next, we'll be looking at the impulse felt by the player after he's caught the ball. For the second problem, which is again, what is the force felt by the receiver, we're able to use the impulse value that we found in the first problem, and we equate that to the force over change in time. And that way we're able to see that the force felt by the receiver is 1.38 newtons. And now we'll look at the work done by the thrower. Now looking at problem 3, which is again to remind you that if this were an isolated system, that we're now calculating the work done by the player on the ball. Per definition, work is the change, or delta, in all forms of energy, including kinetic, gravity potential, and thermal energy. And all of the variables using calculating kinetic, potential energy, and thermal energy are all given by the problem setup, including mass, velocity, and height. Therefore, we're able to find it fairly easily. Now, using those variables of mass, velocity, height, and gravity, which is a constant on Earth, we're able to find the work done on the ball by solving for delta K, delta U sub G, and ultimately finding the work done, which is 10.74 joules. Now moving on to problem 4, in which we're going to use the work that we just calculated to find the force that the thrower receives from his motion. And the hint here is that all objects in this system act as an action-reaction pairing. Now using that work that we just calculated, as well as the displacement of the ball by the thrower, we're able to find that the force is 0.783 newtons. Then this figure is the last one that we wanted to find and completes the 4 questions that we've been looking for.